Hello, everyone. I'm Nipun Agarwal, and today I'm going to be talking about the MySQL database service in HeatWave. There are four topics I'm going to be covering today. I'll start off with an overview of the MySQL database service, followed by an overview of MySQL HeatWave, and then I'll give an introduction to MySQL Autopilot, which is a feature which has been recently introduced to MySQL HeatWave. And finally, I'll share some benchmark results and feedback from customers. The MySQL database is the most popular open source database in the world. Over the last several years, and looking at various variety of feedback and service, MySQL has held the dominant position as being the most popular open source database. Since last year, we have been offering the MySQL database as a managed service in Oracle Cloud, and it's called the MySQL database service. In addition to doing the various things you would expect a managed database service to do, for instance, automatic backup, automatic provisioning and configuration, automatic patching and upgrades. One of the very unique things of the MySQL database service in Oracle Cloud is that this is the only MySQL service which has been developed, maintained, and supported by the same MySQL development team, which offers the MySQL database. So this is something which is very unique, and we're able to provide a very high quality of the service because of the fact it's been developed and managed by the MySQL development team. The other aspect which is very interesting and unique to the MySQL database service is that it is offered at a fraction of the cost compared to other vendors. MySQL is offered as a managed service pretty much by all the cloud vendors, whether it's Amazon, Google, Alibaba. But the cost of the MySQL database service in Oracle Cloud is about 1/3 of Amazon or Azure or Google Cloud. So not only is the MySQL database service managed and maintained by the MySQL development team, which is a major upside, but it is also a fraction of the cost. Enterprises across the world use MySQL for a variety of applications, right from social, like Facebook, Twitter, heavy users of MySQL, to e-commerce, to technology, to finance, manufacturing. Enterprises across the spectrum use MySQL. However, MySQL has been designed and optimized for transaction processing. So most of the applications out there use MySQL, but they use it for transaction processing. When the time comes for running analytics, traditionally, customers would move the data out of the MySQL database into a database which is more suited for analytics. And this database could be on-prem or it could be in the cloud, like for instance, Redshift or Snowflake, and that's where people would run analytics. So customers would have to move the data out of MySQL database into another specialized database. So they would have to do this ETL process in order to get good performance for analytics. Now, having two different databases has a lot of downsides. Customers need to maintain and manage two different databases. The semantics may be different. The whole process of moving the data from one to the other database means that the data is no longer in sync. Right? So it's never real time. There is some amount of latency in the delay, like in moving the data. And also there is an additional complexity which applications need to incur. With MySQL HeatWave, which we introduced in last December, customers now have a single MySQL database on which they can run both OLTP applications as well as analytic applications. HeatWave is an in-memory query accelerator for MySQL, which accelerates a whole spectrum of queries. So all the data can reside in the MySQL database. Customers will get very good performance, both for their OLTP transactions as well as for complex queries. Since the data no longer needs to be moved across databases, any changes which are made by the transaction processing statements are visible right away to the queries in the analytics system. Furthermore, these changes had been done such that all existing tools and applications which are compatible with the MySQL database continue to work as is. HeatWave has been designed for massive scalability. So the system scales to thousands of cores, which is something which is very important in the context of a cloud service. The MySQL database has been enhanced. Specifically, the query compiler component of the MySQL database has been enhanced such that whenever a query comes in, the query comes in to the MySQL database, the MySQL compiler intercepts the queries and it makes a cost-based determination whether the query should be executed by the MySQL database or it should be offloaded to this HeatWave query accelerator. If it is determined that HeatWave is going to be more conducive or more cost-effective in executing the query is transparently pushed to the HeatWave engine. The processing is done. The results are sent back to the MySQL database and then back to the application. So there are two parts over here which are noteworthy. One, the application is always interacting only with the MySQL database. The existence of HeatWave is completely unknown to the application. Secondly, it is the MySQL query optimizer which makes this decision transparently whether the execution is being done in the MySQL database or HeatWave. So from an application perspective, this is extremely desirable because it obviates the need for the applications to make any changes in their application. So all existing tools and applications work as is. MySQL HeatWave has been designed for performance and cost. And there are three reasons why we are able to achieve very good performance and cost with HeatWave. The first thing is it's been designed for scalability. HeatWave scales to thousands of cores. And one of the reasons is that we have invented, designed, and implemented new algorithms so that they can scale to thousands of cores. Secondly, MySQL HeatWave has been optimized for the Oracle Cloud. So we have gone at length to optimize for the various shapes available in OCI. We have optimized for the specific storage we have. For instance, considering what is the object store bandwidth we get, we have optimized it for the OCI network. As a result of these optimizations, we are able to get extremely good performance at a very low cost. And finally, there is pervasive use of machine learning throughout the stack, both on the MySQL side as well as HeatWave. As a result of these three design points, MySQL HeatWave offers very compelling performance at a very low cost. And we will show us these results in a later segment where we will show that MySQL HeatWave offers the best performance at the least cost compared to all the other competitive analytics services, including Redshift, Snowflake, Google BigQuery, Azure Synapse. One of the fundamental design points for MySQL HeatWave is that it has a massively parallel architecture, which is aided by a massively partitioned architecture. When the data is read from the MySQL database into the memory of the HeatWave engine, the data is partitioned at near memory bandwidth in the memory of HeatWave, and this partitioning is done such that it is aware of the workload. So depending upon the queries and depending upon the data, the kind of keys which are used for partitioning may change. So the first step is while reading the data is massively partitioned, and it is partitioned at a granularity such that each of these partitions can fit in the cache of the underlying processor. The next step is that as the data is partitioned, it fits in the cache of the underlying processor. And when the query execution starts, the algorithms are able to read the data with very low latency because these partitions can be fetched from the cache. And finally, the query algorithms are such that they can process these partitions at a very effective or very high bandwidth. As a result, the end-to-end processing of the system is extremely efficient. So one of the key things about any service in the cloud is scalability. So I want to share some results over here for scalability. This is showing the scalability of end-to-end queries for MySQL HeatWave. And this is across 60 different servers and about 30 terabytes of data. As you can see, as you go from 2 nodes all the way to 60 nodes, the throughput of the system continues to be very, very high. We achieve a scale factor of about 0.9. So what that means is that as you add more nodes, as you add more servers, the system scales almost linearly. And this leads to very good performance of the system, even at large data sizes. Although MySQL HeatWave is offered in the cloud and it's optimized for the cloud, there's a very large set of customers who have the data on-premise and who are unable to migrate all the data from on-premise to the cloud. So for that, we offer a unique deployment scenario, which we call the hybrid deployment scenario, whereby using standard MySQL replication, customers can replicate their data from on-premise to the cloud. Once the data is replicated, they can then run analytics in the cloud, and they can continue running their transactional processing applications on-premise. Once they're done running the analytics in the cloud, they can suspend, stop, or they can just keep it live. But there's a provision where by having this kind of a hybrid deployment, customers can maintain their own premise application and still get the benefits of the good performance and cost of MySQL Analytics in the cloud. Now let's briefly talk about MySQL Autopilot, which was recently introduced. As a cloud provider, as a service provider, we believe that cloud provides a lot more opportunity for automation. The reason is that when an application is running on the cloud, we know exactly what is the shape on which the application is running. So for instance, we know exactly what the hardware characteristics are. We know exactly what is the software version of the database, the software version of the underlying operating system, even the software version of the underlying firmware. We know exactly the information about the configuration parameters. One of the very challenging things is that if customers are running an application on-premise, and if they run into an error, one of the things which often goes wrong, or which is often difficult to kind of assess, is that what are the configuration parameters? When an application is running in the cloud, it's information which we handily have, the configuration parameters. The various metrics in the real time are available in real time. So for instance, we know how much of network data is flowing. We know exactly how much of compute is being utilized. And finally, we know what is the optimization target. For instance, is that application being optimized for throughput? Is it being optimized for latency? So as a result of all of this, an application which is running in the cloud, we have a lot more information, and therefore we believe there's a lot more opportunity for automation. The approach which we have taken for automation is to use machine learning as opposed to a rule-based approach. And that there are multiple advantages of machine learning-based automation. The first thing is that the machine learning model is specific to the instance. So if you have an application which is running in the cloud, the model which we come up with is specific to your instance. As your application changes, as the data characteristics changes, the machine learning models are able to adapt in real time. And what this does is that this makes the system become more intelligent over time. As you run more queries, as the system keeps running for a longer duration of time, the system gets more intelligent. In addition to being able to make a prediction of what is, say, the right configuration or what is the right choice for a given partitioning key, the system is not only able to make the correct prediction, the system is also able to predict what is expected improvement you're going to get by making these changes. And I'm going to show some examples like in one of the following slides. So by using machine learning for automation, the system gets more intelligent over time. And this is something which is very unique to MySQL Autopilot. So in MySQL Autopilot, we are offering 9 features, and these features cover the entire gamut of the service lifecycle, right from the service setup to data loading to query execution and finally failure handling. The features which are shown during the system setup and data load, these are exposed via an advisor, where the system makes a recommendation and the user can choose to either follow the recommendation or they can override the recommendation. The features which are a part of the query execution and failure handling, these are always enabled by default and the system enforces them, and there is no way for the user to override. In order to deliver these features, we have made extensive enhancements to MySQL HeatWave. Now, as most of you probably realize, that to come up with a good machine learning approach or machine learning application, there are 2 things which are important: data and the models. So the first thing is we have enhanced various aspects or various parts of MySQL and HeatWave to collect new kinds of data. So for instance, in addition to collecting the data statistics, we also collect information about query statistics. So for instance, we have information about the pre-execution query time, the post-execution query time. And then for the machine learning models, we have created several models. For instance, one which models the query performance, another one which models the dictionary size. There's another model which we have for the network characteristics. So a lot of innovation in the data and then in models. In addition to collecting new kinds of statistics and building these models, we have augmented them with a lot of innovations and inventions which we have done at Oracle. So for instance, when we collect the data, not only do we collect data and new kinds of data, but we have some very unique approaches, novel approaches for sampling a very small amount of data, yet achieving very high accuracy. We have come up with proprietary algorithms to do statistics extrapolation, which is why even by sampling a very small percentage of the rows, which makes the system very performant, we are still able to achieve very high accuracy. And then for the machine learning models, we have used Oracle's AutoML to be able to build and train these models. Because if you were to do these by hand, it would be extremely time consuming and expensive. Whereas by using Oracle's AutoML, it is automated and it's very, very performant and accurate. So these are the various enhancements we have done in MySQL Autopilot, as a result of which we are able to deliver these features with a high degree of accuracy. So what I'm going to do now is to walk you through some of the features of MySQL Autopilot. Auto-provisioning is the first feature during the system setup. So if you look at any system out there, whether it's Redshift or whether it's Snowflake, the onus is on the application to determine what is the right cluster size for a given workload. And this is something which is not very easy to do, and it's very error prone. With MySQL HeatWave, the user can invoke the auto provisioning advisor, where the only input which is given to this auto provisioning advisor is the data set on which the user would like to run analytics. When the user provides the data or the names of the tables on which the system would like to run analytics on, the system samples a very small percentage of the rows, and based on that, it's able to determine exactly the memory footprint for those set of tables. So what we saw is that by sampling less than 0.1% of the rows, the system is able to predict with more than 96% accuracy the memory footprint and therefore the size of the cluster. This is something which is very unique and no other database offers this. The second feature I want to talk about is the auto data placement. So once you have created a cluster. The next step is to load the data from the MySQL database into the memory of the cluster. Now, the performance of the cluster or the performance of the system depends significantly on the queries which are being run and the data movement. If there's a lot of data movement between the nodes, the performance of the system is going to suffer. What auto data placement does is that it looks at the queries which are being executed, and it makes a recommendation to the user as to what are the keys, what are the columns on which the data should be partitioned such that it minimizes data movement. Not only that, not only does it make a recommendation of the keys on which the partitioning should be done, it also predicts exactly the amount of improvement the application is going to see if they follow that recommendation. This is something which is, again, very novel. No other database service offers that. So by making a recommendation which is based on the queries and by giving a quantification of what are the benefits, the user can then decide whether they want to go with the follow the recommendation or not. So for instance, if the expected improvement is very small, then the user may decide to pass on the recommendation because it will take some time to repartition the data in memory. The third feature which I want to talk about is the auto query plan improvement. Here, the system learns from the queries which are being executed. And based on the queries which are being executed, the system is able to improve the execution plan of subsequent queries. So an example over here is that if there's a query which has three columns or three tables, A, B, and C, and it's doing a join, and the system would learn from it. And then in the future, if it sees a query which is related to this, for instance, it still has the constructs A, B, and a join, but it has a different table B where there's a union operation, the system is still able to learn or benefit from the A join B aspect of it and come up with a fairly good plan for this new query, which it has never seen before. Just by this feature alone, we found that there was a 40% improvement in TPCH and TPCDS workloads for 25 terabytes. Okay, so I talked about the technology or the innovations in HeatWave, and then I talked about MySQL Autopilot. At the end of the day, HeatWave is an accelerator to MySQL database service. So now what will be interesting to see is that how much of an improvement do all of these innovations make? Now, one thing which I want to remind you is that in the database, and this is like feedback from Gartner, the only metric which matters is price performance. So what I'm going to show you is for a variety of cases, how is the price performance of MySQL HeatWave compared to other services? So let's start looking at the performance of MySQL HeatWave compared to MySQL running in AWS with RDS service. HeatWave is 5,400 times faster and at 2/3 of the cost. And this is for 4 terabytes TPCH. So on an average, on RDS, it takes 11 hours to execute a TPCH query, whereas it takes 8 seconds with HeatWave. And HeatWave is cheaper. Now, let's compare the performance of MySQL HeatWave with Aurora, because in Aurora, like Amazon has taken MySQL and it has like made a bunch of enhancements and they offer that as a service. Now, even with Aurora, on an average, after creating all the appropriate indexes and all the tuning, on an average, a query takes 2.5 hours for 4 terabytes TPCH. Whereas with HeatWave, it takes about 6 seconds. So this is about a 1,400 times improvement in performance. And HeatWave is half the cost. So if you look at the price performance advantage of HeatWave, it's 2,800 times better than Aurora. Now let's compare. So both RDS, MySQL, and Aurora, you can think of them to be general purpose databases. Now let's see what is the performance of MySQL HeatWave with services which are optimized for analytics. And there, the key services which we are comparing with are Snowflake, Redshift, Azure Synapse, and Google BigQuery. And this is on 30 terabyte TPCH. What is interesting is HeatWave is faster than all the other services, and it is cheaper than all the other services. So typically what happens is you can build a service which is faster than the others or one which is cheaper than others. Here, HeatWave is faster and cheaper than all the other services. Even on much smaller data sizes, like say 100 gigs, even there we find that HeatWave is about 18 times faster than Aurora at about 42% of the cost. So it offers about 42 times better price performance than Aurora, even on small data sizes. Now, this is the benchmarks. Let's see what do some of the production customers have to say. This is Red3i, which moved around 6 terabytes of data from Aurora to the MySQL database. And what they are finding is that they saved 60% by moving from Aurora to MySQL HeatWave. They didn't have to change their application. And on an average, their queries improved by 85%. Some of the queries improved by 1,000 times, but aggregate, the overall workload improved by 85%. Another example, Tetris. They also migrated from Aurora to HeatWave. Very similar experience. Didn't have to change their applications. Query performance improved from taking minutes with Aurora to milliseconds with HeatWave, and the cost reduced to half of Aurora. Fan communications, same experience. Didn't have to make any changes while moving from Aurora to HeatWave. And in this case, they found that the aggregate performance improved by 10 times compared to Aurora, and the cost dropped significantly. Tamara, another example where they found that the cost reduced by about 3 times. HeatWave accelerated many of the queries. And since the performance of HeatWave is so much better, what they observed is that they could actually enhance their application by writing more complex queries, which would execute in a reasonable time, which was not the case earlier. So consistently across the board, we are finding that all the customers who are migrating to HeatWave are finding better performance, lower cost, and minimal changes to their application. So to summarize, MySQL database service with HeatWave is the only MySQL service which offers efficient processing for transaction processing, analytics, and mixed workload. It offers the best price performance for analytics compared to all the competitive services. For instance, it's 35 times better price performance compared to Snowflake. It's 13 times better compared to Redshift Aqua. It's 36 times better compared to Google BigQuery, 15 times better than Azure Synapse. MySQL HeatWave also offers very good price performance for mixed workloads. It's 42 times better price performance compared to Aurora for mixed workloads. MySQL HeatWave is the only MySQL service which offers machine learning-based automation via MySQL Autopilot. MySQL database service supports hybrid deployment, where customers can have part of their application running on-premise and transparently move some of the application to the cloud. And finally, and perhaps a very important aspect is, this is the only MySQL service which is developed, maintained, and managed by the MySQL development team. And it's always on the latest version of the MySQL database. We welcome you to try the MySQL database service with HeatWave. And you can go to this website to get information as to how you can get $300 of free credit. And if you would like more information on the MySQL database or HeatWave, please visit us on the website. Thank you very much for your time.